We have the fundamental identities from chapter 5 that we're going to draw upon. So there's two families of identities I'm going to use. The negative angle identities and the cofunction formulas. So the first thing I'm going to do is I've got cosine of u minus v equals cosine of u, cosine of v, plus sine u, sine v. Well, the question would become, what's cosine of u plus v? How can I use this based on previous information? Well, let's go back to chapter 5 and recall the negative angle identities. Here's angle t, and here's angle minus t. The points here, xy, the point here, x negative y. What this tells me is that the cosines of opposite angles are equal, and the sines of opposite angles are opposites. Well, I can look at cosine of u plus v, and I can rewrite it as cosine of u minus a minus v. Nothing earth-shaking there. All I did, because a negative times a negative equals a positive. Well, now that I've written it though in this form, I can then use this identity that I've already derived to derive another identity. So I take this and I write cosine of u, cosine of minus v, right? Because minus v is my second angle, plus sine of u, whoops, who wrote that scribble? Sine of u, sine of minus v. Well, again, I went back and I did this for a reason, because we're going to apply this. Again, cosines of opposite angles are equal. So cosine of minus v is the same as cosine of v. So by substitution, I get the first term in the expression. But sines of opposite angles are opposites. So when I replace here, I get minus sine u, sine v. So there's my addition formula. There's my addition formula for cosine. So it was like a buy one, get one free. I had to do all the big long work using the distance formula and all the properties from geometry about congruent arcs and congruent chords, and manipulate down, simplify terms, use Pythagorean identities, all that stuff, and I got the first one. But to get the second one, man, that was fast. Snap. All right. Well, great. I've got two. But wait, there's more. I know you're saying, man, this is just, it doesn't get much more exciting than this. Well, it does. So where are those cofunction formulas? All along I've been harping on cofunction, and you're saying, when am I ever going to use a cofunction formula? Well, let's take a look at this. Suppose I want to say sine of u plus v. Well, immediately, I know your brains aren't just leaping ahead, being the brilliant students that you are, and you're saying, oh man, sine of u plus v, obviously that's equal to the cosine of its complement. So what's the complement of u plus v? Well, we all know that it's cosine of pi over 2 minus u plus v. Voila! If this is an angle theta, then that represents its complement. Beautiful stuff. But if I were to expand this, I wouldn't really get anything good. But I can do a little mathematical trickery. And here's the little mathematical trickery that I'm going to do. And we did this earlier when we were talking about the conjugate roots theorem in chapter 3. And we were trying to create a polynomial function out of knowing its complex zeros. We removed or moved the position of the parentheses in the expression. And that's all I'm going to do here. I'm going to rewrite this as pi over 2 minus u minus v. All I did was change the parentheses here. Distributed negative sign inside, change parentheses. And now I'm going to use the subtraction formula for cosine. This right here. So using that, here's my first angle alpha. So I write cosine of pi over 2 minus u, right? Times cosine of the second angle, which is v, plus, right? It's minus in here, it's plus there. Minus sine of the first angle, pi over 2, minus u, times sine of the second angle, sine v. But wait! Oh boy, oh boy, oh boy, oh boy! Cofunction formulas, cofunction formulas. What is cosine of pi over 2 minus u? It's equal to sine u. Sine u cosine v. Plus, what's sine of pi over 2 minus u? It's cosine u. And I've derived the addition formula for sine. What a beautiful thing that is. What a beautiful thing. I know you're going, gosh, how much more can I take in one day? Well, we're only halfway there, gentlemen. 3 down, 3 to go. Let's erase up there. Because we're going to use the addition formula for sine to derive the subtraction formula for sine. Because subtracting something is just like adding its opposite, right? So let's look at sine of u minus v. So I'm going to rewrite that as sine of u plus a negative v. Well, that's not bad, because now I can just substitute into this formula that I just derived. This becomes sine of u cosine of minus v plus cosine of u sine of minus v. But wait! There come those negative angles again. And we're up on our fundamental identities from chapter 5. We remember our negative angle identities. Cosines of opposite angles are equal. So the first product just becomes sine of u cosine of v. Sines of opposite angles are opposites. So this becomes minus cosine of u times sine of v. And voila! The subtraction formula for sines. So we've got addition, subtraction formulas for cosines. We've got addition, subtraction formulas now for sine. Let's not go off on tangents, but that's what we got to do now. I'm going to go off on a tangent here, and we're going to use some more fundamental identities from chapter 5, and we're going to look at the expression tangent of alpha plus, or let's go u plus v. Since we've been sticking with u and v, we don't want to get burned. That's why I should have used SPF, but I didn't. So, tangent of u plus v. Going back to our fundamental identities. Is it possible to rewrite tangent in terms of sine and cosine? Ah, yes! I remember. I can write this as sine of u plus v over cosine of u plus v. And you're going, oh, but don't we have formulas for this? And of course we do. So, it's sine of the first angle, cosine of the second, plus cosine of the first, sine of the second. There's our addition formula for sine. Now I want to work with the cosine. Cosine of the first times cosine of the second, minus sine of the first, sine of the second. But we want to get an expression that enables us to rewrite tangent of u plus v in terms of tangent of u and tangent of v. Not terribly difficult. If we look at our denominator, I have cosine, cosine, sine, sine. If I multiply top and bottom by 1 over cosine u, cosine v, 1 over cosine u, cosine v, beautiful things happen when I distribute inside. So let's see what beautiful things await. My first numerator becomes sine u, cosine v, over cosine u, cosine v. That's this times that. The second term in the numerator becomes cosine u, sine v over cosine u cosine v. Let's try the same thing down below. I get cosine u cosine v over cosine u cosine v minus sine u sine v over cosine u cosine v. Now, if you've been working on your Kung Fu mathematics, there are a lot of things that are going to divide out here. Let's see. Hiya, hiya! Hiya, hiya! Hiya, 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 hiya! Wow. Well, what's left? Sine u over cosine u, we know from chapter 5, is equivalent to tangent of u. Sine v over cosine v is equivalent to tangent of v.